Hi there, welcome to this video. I'm Dr. Fredrik Wallinder. As you know, exoplanets are planets outside our solar system. And in this video I'll go through some ways that astronomers use to get knowledge about them. The hunt for planets has barely begun, since current technology limits us to systems nearby. Our galaxy contains billions of stars, so it's premature to base far-reaching conclusions on a sample of just a few hundred planets. But we must, of course, start somewhere. The so-called Doppler method is a way for astronomers to get a low limit of the mass and the orbit characteristics of the planet. It works because the gravity force from the planet moves the star back and forth as they move around a common center of mass. The effect is very small, since the star is much heavier than the planet, so astronomers must use very detailed spectra from the stars to detect it. Let's look at a short animation of how it works. Notice how the line wavelengths change as the star moves due to the Doppler effect. This method has produced hundreds of discoveries since the first one in 1995. Before that, people thought that our solar system should be typical, with small high-density planets near the star and large, low-density ones further out. The reason was that the heat from the protostar should evaporate the lighter stuff from the inner planets, whereas the outer planets should keep it. First observations were shocking, since Jupiter-like planets were found close to their star. Let's take a look at the graph from exoplanets.org over the distribution of known exoplanets versus their orbital period, which is the time it takes to go around the star. The pink region on the left is the hot Jupiters. They go around their stars in a matter of days. It's difficult to imagine that they were born there, so they must have migrated inward in the disk from the formation site early on. We are very lucky that our Jupiter didn't do that, since its gravity would have perturbed Earth's orbit, making life very difficult. The second plot from exoplanets.org shows the mass distribution of some 400 planets. It's clear that planets with small masses are more common, at least in this sample. Could be that it's simpler to form small rocky planets as a byproduct of star formation. The last graph from exoplanets.org shows how circular the orbits are. Value equal to 0 on the y-axis means that the orbit is circular. You see that many of them have elongated orbits, so that their distance to the star varies a lot. Yellow or green dots indicate Jupiter-like planets, and we can see that their eccentricity is about 0.3, so the distance to the center of mass varies with a factor of 2 along the orbit. It follows that Earth-like planets may have a hard time remaining in their orbits in such systems. Another thing to note is that planets orbiting close to their star tend to have circular orbits, as seen in the left-hand part of the diagram. One problem with the Doppler method is that it requires high-quality spectra, so it only works for stars within a couple of hundred light years from Earth. A promising way astronomers use to infer the radius of an exoplanet is called a transit method. It works as follows. Let's assume that the orbital plane of the exoplanet is very close to the line of sight. The brightness of the star will then drop as the planet blocks some of the stellar light as it passes in front of it. The variation is small, up to 1%. Using the light curve, the astronomers get information about the planet's size, since the big planet produces a sizable dip and vice versa. Now the real fun begins, since the mass from the Doppler method and the radius from the transit method can be combined to give us information about the density of the planet. Why is that important? The answer is that a low density means that we have a gas planet, and a high density means that we have something that could resemble Earth. This figure shows how the calculation is done. The density is mass divided by volume, and it comes out from the expression below, assuming that the planet is spherical. The prize winner among planet hunters is a new Earth in the Goldilocks zone, where life can exist. A few results as to Earth-like planets have already surfaced. It's interesting that the Kepler mission team recently announced some 1,200 suspected planets discovered using the transit method, of whom about 50 orbit in the habitable zone. But much work remains, since they need to be verified using the Doppler method. The Kepler spacecraft is sensitive enough to detect planets smaller than Earth, so I think we can expect a lot of interesting results from that mission. It's already clear that there is a huge variety among the systems, probably due to how violent the formation process was. The other missions going on are being planned right now, but there is not enough time to discuss them here. So how about a new Earth waiting for us out there, perhaps with life already present? There are several requirements, such as the right kind of star, a suitable distance between the planet and the star, and presence of liquid water. One fairly good indication of life would be oxygen in the atmosphere, since life as we know it produces that gas in abundance. Even though these assumptions may be narrow-minded, they are a good start. Let's look at how Earth would look like to aliens observing us today. This video is from the Epoxy spacecraft. Notice the moon passing by. The brown color is real. So if we could image the exoplanet directly, we could find out whether it has oceans, continents, and so on. Taking a spectrum would reveal the presence of life and water. The next generation of telescopes in space and on the ground will therefore look for these characteristics, using some special tricks. The positive detection of life on an exoplanet would probably be the biggest scientific discovery so far. Many astronomers feel that there should be lots of places with simple bacterial life, but that intelligent life is very rare. Others take the opposite view and regard intelligent life as common. Simple truth is that nobody knows. Let's however assume that we find an interesting exoplanet and that we need to go there for some reason, perhaps a disaster of some sort. Is that possible? The short answer is no, not with current technology. The travel would take too long for our species, which is adapted to life here on Earth. But improvements to ourselves, coupled to technological progress, should one day permit travel to other stars. The investigation of nearby exoplanets would then be the first step in that process. You can check out more about this topic in the video entitled The Space People. That's all for today. If this video was of interest, please subscribe. Until next time, goodbye.